Now let's consider a little bit more complicated proposition. This one is not P or Q. It may be confusing, but this is not equal to not P or Q. But this should be read as not P or Q. So they are different. To see this, let's make the truth tables of both of these. So P, Q, and true, 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 false, false, true, false, false, and POQ is true, 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 false, and not POQ is opposite of this. So it's false, 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 true. And not P is, let's see, this is true, so false, false, true, true. So not P or Q should be this or this. So that's true, this or this. So it's false, this or this. So it's true, this or this. So it's true. So if you compare this column and this column, you see they're different. It's true, false, true, false, 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 true, false, true, true. So apparently this line. So this case, they're different. And also this case. So in general, this unary operator binds more strongly than this binary operator. So that's why this does not mean this, but this. Alright, so far we have learned conjunction and disjunction and negation. Okay. So these three operations are actually all we need for any kinds of logical inference in propositional logic. Nevertheless, we define yet another operation called implication. Okay. This is not strictly necessary because this can be derived from these three by combining these three. But anyway, we write implication as this. So this is to be read as P implies Q. Or you can say if P is true, then Q is true. Okay. So I think maybe you have seen in some math lectures, we write if P then Q as this. Okay, so this is implication. And this is an logical operation. So we can define this by a truth table as usual. So let's say P and Q. P implies Q. So T false. Sorry. We usually write T here. False, false, true, false, false. Okay, when P is true and Q is true, P implies Q is true. When P is true and Q is false, then P implies Q should be false. When P is false and Q is true, what do you think this is? This is actually true. And same for this. False, false, then it's true. What does it mean? So in implication, this P, okay, this P is premise, and this Q is the consequence, right? So this means if the premise is true and the consequence is true, this whole statement should be true. That's okay. And when the premise is true but the consequence is not true, then it's false. It makes sense. But when premises is false, then this implication is true. This means if you base your argument on a false assumption, then anything can be true. That's what this implies, means. Okay? So that's implication. For example, can you think of an example? Like, let's say P is, let's use black one. It rains. And Q is the road is wet. So P implies Q can be read like if it rains, then the road is wet. If it rains, then the road is wet. Okay. Okay, here's a quiz. Let's say we have this truth table. Can we guess what kind of operation is here that combines P and Q? So this is true, false, true, true. We have just learned that this truth table is satisfied by implication. But before, we have also seen that this truth table is obtained by not P or Q. So these two logical expressions or propositions have the same truth values, truth tables. So what does it mean? That means these two propositions are equivalent. We cannot distinguish these two based on the truth table which defines them. Okay, so actually this implication is the same as this proposition, not P or Q. So that's why we said this is not implication, is not strictly necessary, but we can express this implication in terms of negation and disjunction.